Well, thanks for sending me this big nasty problem from within MathXL. We're looking at an expression, and really all we can do is follow the directions, and the directions say to do this operation, that is to divide, and then to simplify. And so, I of course have a trained eye for these things, so, certain things are jumping out to me that chances are might not be jumping out to you, and that's just because of I've gotten so much more practice with this stuff. But you see, what I'm seeing here is the difference of two cubes. That 27 can really be written as 3 cubed. And here's the difference, and so I have the difference of two cubes, and that can be factored according to this formula right here. You can tease it apart into a binomial times a trinomial. And the same is true for the bottom of this fraction. This is really the sum of two cubes, and that cracks according to this formula. And so I've rewritten it here, down here like this, as the sum of two cubes, 27 being 3 cubed. Now it's a chapter 6 skill that we do this idea called invert and multiply. Now, so you change division to multiplication, and then you invert the fraction, and that's where the sing-song invert and multiply comes from. And so I've written the top on the bottom and the bottom on the top, and I'm showing now not division but multiplication. And I've got another note here too. Again, this is one of those things that a math teacher will espy immediately, and that is the difference of two squares. And I've rewritten it over here as the difference of two squares, and that factors, according to chapter 5, as two binomials that are identical, except for the sign between the two um, terms. And of course, if you were to multiply this out, if you were to do all four multiplications, you would in fact get this back. So this is going to factor, this is going to factor, and this is going to factor. And this trinomial, though, I played with it a little bit before making the movie, and it doesn't factor, but that's actually um, part of the ruse of this problem, is to try and frustrate you with a trinomial that doesn't crack, but lo and behold, it'll end up canceling anyway. So um, one more thing before we actually get into the factoring part here is that as some of your fellow students have noted in the bulletins, and as I always did it on the chalkboard, when you're multiplying two fractions, it's done in very quickly, just by basically creating one big fraction and showing the multiplication between the two parts, because you multiply fractions straight across. And so really what I want to do is factor this, and this, and see what cancels. Now again, this is going to factor according to this formula. And of course I have this memorized by heart, but this was, I think, section 5.6, and you might want to chase back and practice spotting the difference of two cubes and then running this formula on it. Essentially, the top is going to look like this. A binomial times a trinomial. And the trinomial here is going to be this term squared, and then the last term is going to be this term squared, and then the middle term is going to be these two multiplied together. And notice there's all pluses here, so let me get the pluses in. So we got the first term squared, and then we've got this last term squared for over here, and then we just multiply these two together to get 3x. And on the bottom it's going to be nearly identical because we have the same numbers, except we have here this sum of two cubes, and you can see the binomial has a plus here. But it's the same game. The first term is this squared, the last term is this squared, and then the middle term here, though, is actually going to be negative, and you multiply these two together and make it negative. So 3x, and we get a minus 3x. And so then we have this trinomial here, and it doesn't crack, but that's okay. It's a prime trinomial. That's okay because it's duplicated down here, and we'll be able to cancel this in a second. Of course, we know this factors is x minus 3 times x plus 3. And now in effect we have multiplication here, here, here. So think of this as four numbers being multiplied together. And think of this up here as being three numbers multiplied together. And since we have all multiplication of these numbers in the top and these numbers in the bottom, we could cancel them one for one. That means this is going to cancel this, and this is going to cancel this, and that's all that it cancels. And so we have x plus 3x, x plus 3x plus 9 all over x plus 3 times x plus 3, and I'll just leave it in factored form. I know I could multiply that out, but I won't do it. And you're done. Nothing more will cancel, and so you can't simplify this anymore. That's the answer you want to type into MathXL. One thing I didn't want to mention here is that when you have the sum or the difference of two cubes and you run this formula, notice you get a trinomial. And that's what we got here, this trinomial, and down here, this trinomial. Those trinomials will never crack. And so don't even waste your time trying to break this up into two binomials. It will never crack. That's why I just left it like this and didn't even talk about trying to factor it. So this is a very complicated, convoluted problem. There won't be anything quite this difficult on the exam. Thanks for sending this to me, and I hope it helps.